Analysis of vanillin in white chocolate by gas chromatography. Assalamualaikum and hi. My name is Putri Nur Atira Balkis binti Othman. I will present the introduction part about gas chromatography. Gas chromatography is a technique for separating components based on their volatilities, which mean based on differences of boiling point. In this, components of a vaporized sample are separated because of being partitioned between a mobile gaseous phase and a liquid or a solid stationary phase held in the column. The carrier gas is helium or nitrogen. The principle of gas chromatography is the sample will be injected at the inlet or injector and vaporized into the column. The sample is transported through the column by the flow of inert gases mobile phase. As this sample passes through the column, they will be separated and detected electronically by detector. What is vanillin? Vanillin is an organic compound with the molecular formula CHH3. This compound is a phenolic aldehyde which consists the functional group of aldehyde, hydroxyl and ether.
Hi, Assalamualaikum. My name is Muhammad Afiq Najan Benjamili and I'm going to explain about methodology. For sample collection, GC is filled to the predetermined mark with a low boiling point solvent. One drop of the white chocolate sample to be analyzed is placed into the vial using dropper. The vial is capped and inverted several times to dissolve the white chocolate sample. The sample is now ready to be injected into port of gas chromatography. For sample injection, a small amount of liquid sample to be analyzed is drawn into a syringe and injected quickly into the hot injection port of the gas chromatography. Time of the injection is taken at the beginning of the retention time of the analyte. Thus, the injection must be done swiftly. Temperature of port is raised to be higher than that of the boiling point of the analyte, so they will vaporize. The vaporized analyte then is mixed with the inert mobile phase to be carried to the gas chromatography column where separation occurs. For sample separation, components in the white chocolate sample separate based on their absorption rate to the stationary phase according to the polarity. Components that absorb strongly will stay in the column for a longer period and have longer retention time. The inverse is true for component that has low absorption rate. For sample detection, the individual component of the sample appears as different peaks in the chart. This due to the components reaching the detector at different times due to the differing times they are retained in the column. Each peak on the GC chromatogram can be cross-referenced with a known standard to identify the chemical species.
So now I'm going to share about the results and discussion of gas chromatography. The first table shows the predominant odorant identified in milk chocolate by aroma extract dilution analysis. The compound used is vanillin. The retention time for DB wax is 2258. The retention time for DB5 is 1407. Meanwhile, the odor property is vanilla-like and flavor dilution factor is 729. Table 2 explains the concentration of predominant odorants in milk chocolate. The compound used is vanillin and its concentration is 2713 plus minus 16B. The third table shows the aroma active compound and their actual dosage in the modified chocolate. The compound used is vanillin and its concentration is 2713 until 2692. So for this experiment, specimen is being vaporized and injected onto a chromatography column's head. Quantitative data obtained by calculating standard calibration curve of each major active compound. Third point is concentration of vanillin in milk chocolate was 2713 until 2692. The next point is vanillin, which is vanilla-like, reached the highest active factor, which is 729 in at least one type of sample and considered as the odorants that has the most impacts in chocolate. Last but not least is qualitative analysis, which is used with a couple of gas chromatography mass spectrometry to confirm the peak identity.
In conclusion, the complexity of vanilla flavor is demonstrated in this study on vanilla origin and the impact of origin on chocolate taste. Chocolate is a difficult fluid material in which specific flavor compound and food notes can cause changes in sensory perception, while low level of vanilla extract in chocolate are primarily used to round out the overall chocolate flavor profile. Higher level of vanilla extract in chocolate. The gas chromatography results showed that glycol and vanillin are the main product found in the sample chocolate. Thus, analysis of vanillin in white chocolate had been determined. The GCMS method greatly eliminates the interference of complicated matrix in white chocolates. The advantages of this method include low detection limit, good accuracy, precision, and selectivity.
Determination of vanillin in vanilla essential oils by high-performance liquid chromatography. I will explain about high-performance liquid chromatography. HPLC, or high-performance liquid chromatography, utilizes a liquid mobile phase to separate the components of a mixture. The high-performance liquid chromatography is very versatile because of its ability to easily separate a wide variety of chemical mixture, which include non-volatile and thermally unstable compounds like organic, inorganic, and biological samples. For the principles, it begins by injecting the solute onto the top of the column. Separation occurs as the analyzed and mobile phase are pumped through the column. Each component elutes from the column as peak on the recorder. The response of detector to each component is displayed and known as a chromatogram. Vanillin is normally used in flavorings, foods, perfumes, and pharmaceuticals.
I'm going to explain about methodology. For sample preparation, vanilla samples about 1.5 kg were cured by 3 methods: scalding in hot water at 65 degrees Celsius for 30 seconds, drying in the oven at 60 degrees Celsius for 48 hours, and drying in the sun for 20 days and 2 to 3 hours every day. Cured vanilla was fermented and dried in the wind. Therefore, the water content in the cured vanilla decreased from 55 to 65% to 25 to 30%. The signs that vanilla had dried are: vanilla color was super black or brownish black and shine. Vanilla were deflected because water contained about 30%. And vanilla had characteristic flavor and fragrance. The last, cured vanilla was stored for minimum 2 months. The result of cured vanilla were taken at random for pre-extraction. Weigh the whole cured vanilla, about 10 grams for the oxidation extraction and 5 grams for percolation. After that, weigh the cut cured vanilla, 2.5 cm, about 10 grams for the oxidation extraction and 5 grams for the percolation. For extraction procedures, extract the cured vanilla of pre-extraction Z1 in the Soxhlet extraction apparatus with 200 ml of the 99.9% ethanol for 60 hours. Transfer into a 250 ml volumetric flask. Rinse the flask of the extraction apparatus several times with small quantities of the 99.9% ethanol and pour the washings into the volumetric flask. Make up to the mark with the ethanol and mix well. Extract the cured vanilla of pre-extraction Z2 in the percolation apparatus, Allen Mayer. Submerge Z2 about 35 ml of the 99.9% ethanol in Allen Mayer 100 ml for 1 night. Transfer into 100 ml volumetric flask through paper filter. Rinse filter paper with 5 ml of the 99.9% ethanol. Store this paper filter for use at second filtering. Result of the cured vanilla from first submerge was pounded in mortar. Then, submerge again about 35 ml of the 99.9% ethanol in Allen Mayer for one night. After submerge 1 night, ethanol from the second submerge was fused with ethanol from the first submerge through filtered used paper filter, which used at first filtering. Rinse the cured vanilla with 99.9% ethanol and pour the washings into a volumetric flask. Make up to the mark with the ethanol and mix well. For high-performance liquid chromatography (HPLC) UV spectrophotometric, the vanillin was separated on a reverse phase C18 column using methanol acidified water 10 plus 90 and were detected at 280 nm. HPLC apparatus was Shimadzu and UV spectrophotometric was Hitachi. The flow rate of HPLC is approximately 4 ml per minute. For quantification of vanillin content, concentration of standard solutions ppm for calibration curve at HPLC or spectrophotometric method times by initial volume of vanillin solution in liter over sample of weight and times by 100%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Mahudin. Today I'm going to continue this presentation with the result and discussions about the determinations of vanillin in vanilla essential oil by high performance liquid chromatography. Now we move to the result and discussions. Table 1 shows that the linear regression equation and correlation coefficient of the peak area measurements for vanillin standards in HPLC technique and the absorbance in the isospectrophotometrics assay method. Linear relations were observed for vanillin standard between 0 and 4 ppm in correlation coefficient of 0.997 at HPLC and between 0 and 5 ppm with correlation coefficients of 0.999 at UV spectrophotometric methods. Vanillin contents by the HPLC techniques and the isospectrometrics, which is the way we cure vanilla, were 10 gram for salt halation and 5 gram for percolations is shown in table 2. Now we move to the table 2. The table 2 shows the amount of vanillins for the 12 samples were determined by HPLC techniques and the isospectrometric assay method. The data shows that the 12 vanilla samples analyzed and the spectrophotometrics assay consistently yield the highest value than the HPLC technique. The possible explanation for this in the spectrometric assay method, vanillin is not pure, which is mixed by other substances and absorbed at the same wavelength area. This will cause high absorptions. Although HPLC use detector UV, but the sample goes through C18 column and is sprayed before it's come to detector, and this also caused of the vanillin with detector, and this also indicate relatively smaller analytical result. However, the accuracy of this method is much better. The use of UV chromatography is accurate. Which sample is sprayed firstly using the special chromatography column. This way will obtain the same result with the HPLC method with the standard deviation less than 1%. The present data are in agreement with previous data report by Taylor. The amount of vanillin for samples determined by isospectrophotometric assay yield higher than HPLC method. Now we move to the discussions. This investigation were carried out by using HPLC analysis. Based on amount of the required vanillin standard, the concentration of vanillin standard is 3.5 ppm. In the same measurement conditions, the analytical result using HPLC are 3.49, 3.51, 3.48, 3.48, 3.49, with the average of all the result is 3.49 ppm. As a result, the recovery procedure obtained can be calculated to be 99.77%. This result demonstrates that the method used to determine the concentration of vanilla using HPLC is sufficient for the following measurement.
Because there is perfect contact between the vanillin component in the vanilla sample and the extraction solvent, the pre-extraction treatment for cured vanilla slice about 2.5 cm resulted in higher vanillin content. The vanillin content obtained from the solution extraction is greater than obtained from the percolation extraction. This happened because the solvent purity process in the solution extraction is ongoing. As a result, the density of vanillin in vanilla extract is high. The HPLP method is more accurate than the isospectrophotometric assay for determining the vanillin content of vanilla because vanillin is separated from other compounds by the HPLC method. The advantages of this HPLC method are extremely precise in identifying and quantifying chemical compound and high separation power with sensitive detection. Its limitations include a lack of universal detector and less separation efficiency than capillary gas chromatography. So that's all from us. Thank you.